Yes, good morning to all. Good morning, sir. Last class we have discussed about the introduction about the composites. What do you mean by composites? What are the classification of composites based on various criteria? And we have discussed something about the matrix and reinforcement functionalities in the composites. Now this class we will see about the starts from the introduction and elaborately we will discuss about the polymer matrix composites processing methods. As discussed in the last class, we know very well that composite material is an amalgamation of more than one material to get the superior properties which cannot be attained by constituent material, individual constituent materials. Only condition is that, what is the condition? The last class we have discussed, at least any one of the constituent material should retain its physical identity, physical shape. Okay. So any one of the constituent material should retain its original physical identity after processing. Okay. For that we have quoted some example as the reinforced cement concrete. So in the reinforced cement concrete, the coarse aggregate, Jallin Sonolia, the coarse aggregate will retain its same shape and size even after processing or after curing. Okay, that is the one good example of the composite material, reinforced cement concrete, whether it may be a steel reinforced cement concrete or plain reinforced cement concrete. Okay. The composites are broadly classified into three categories that we have discussed in the last class itself: polymer matrix composites, metal matrix composites, and ceramic matrix composites. That is based on the matrix material used. Okay, irrespective of the reinforcement materials. The reinforcement material may be of anything. In the case of polymer matrix composites, polymer will be used for binding the reinforcements. In the case of metal matrix composites, metals will be used for binding purpose. That is the metal matrix composites. The reinforcement may be of any category. That may be another metal, or it may be a non-metal, or it may be a plastic, or it may be of any kind of material. Okay, the reinforcement doesn't come to the picture while classifying the matrix under PMC or MMC or CMC. That is based on the matrix materials used. Based on the nature of origin, the composites may be classified into two categories: natural composites and man-made composites. Okay, natural composites also we have quoted some example in the last class. Can you tell me what is the example? Last class we have discussed wood, natural wood, human bone is also a composite. Okay, these are the natural composites. Man-made composites, fibrous composites, or cement concretes. These are all comes under man-made composites. And based on the reinforcement, the composites are classified into three categories. The one is missing in this slide. The first one is the fibrous composites. Next one is the particulate composite. What is the third one? Laminated composites. Very good. So there are based on the reinforcement nature or reinforcements dimension. Whether if the reinforcements are in the form of fibers, then that is called as fibrous composites. If the reinforcements are in the form of particles, then that may be called as particulate composites. If the reinforcements are in the form of laminates, the example we quoted as plywood. Okay, plywood is the laminated composites where n number of small sheets or small thickness sheets has been stacked to get the required amount of thickness. Okay. The example of a particulate composite is the reinforced cement concrete. Right. And this is the classification based on the research side. This is based on the classification based on the research side, or you can call it as classification based on the within the particulate composites. So based on the particle size, how the composites may be classified. If it is the particles are in a macro level, then that may be called as a macro composite. If it is in micro level, then that may be micro composites. If the particles are in the form of nano particle size, then that may be nano composites. So this is the example. In the case of macro composites, the radius of each particle will be more than 6 mm. In the case of micro composites, the particle radius will be in the range of 40 microns. In the case of nano composites, particle size will be 1 nanometers. Okay. So this is the three examples, diagrams have been given for classification of macro, micro and nano composites. Let us assume three composites blocks have been manufactured with the same dimension. Okay, with the same dimension. Say for example, the case of macro composites, the dimension will also be the same. Here also the dimension will be the same. Here also the dimension will be the same. If you take within this dimension, only there are two particles occupied as the reinforcement. The remaining light blue color are matrix material, binders. Okay. If you take in the case of micro composites, there are 6 reinforcements are there. The remaining will be matrix material. If you take here, more number of reinforcement particles are there and appropriate amount of matrix material. So some proportions will be there. Say for example, what will be the amount of volume occupies these two reinforcements, that will be called as volume fraction of the reinforcement, volume fraction of the composite. If this is 100% volume, if these two occupies 40%, then that may be called as 40% reinforcement in the composites. Okay. If it occupies 60%, 60% reinforcement. Like this, the volume fraction of the reinforcement will be classified. So among these three types of composites, can you tell me which one will give the more amount of strength compared to the macro, micro and nano? Nano composite. The reason is? Very good. The reason is the composite materials strength is purely depends on bonding property of the matrix. How much amount of the bonding of the matrix material sticks with the surfaces of the reinforcement, or particle or fiber or whatever it may be. So the bonding strength will directly proportional to the composite strength. If the bonding strength is good, then the whole composite strength is good. Okay. So in the case of macro composites, the surface area of the two reinforcement will be lesser than that of the surface area of all the reinforcement in this plate. Okay. So here the surface area is higher. The surface area is higher here, and accordingly on all surface areas you will get the higher amount of bonding strength. That is why nano composites will have higher strength compared to the macro composites. So whatever it may be, whether it may be a macro, micro or nano or laminated composites or fibrous composites, so some portion of the material will be occupying as the reinforcement, and the remaining portion will be matrix material. So by seeing this diagram, you can able to list out what will be the functions of matrix and reinforcement. What will be the functions of matrix and reinforcement? If we just take it here, what is the purpose of this matrix? Light blue color. Okay. So it binds these two materials, and during application, it helps to hold these two particles at the same place. During loading time, the particles should not move here and there. Okay. In such a way, this matrix will arrest. Okay. It helps to hold the reinforcement in the appropriate place. And if you are applying the load, where the load will be applied? On the matrix surface. Okay. And this load will be transferred to reinforcement, and from here the load will be transferred to here, and finally the load will be transferred to the component or some other place. Okay. So the matrix will be helping to transfer the load. Very good. The matrix will be helpful for transferring the load from one reinforcement to another reinforcement. Okay. And also it protects the reinforcement from other environmental degradations or other problems. Okay. If there is any corrosive environment, since the matrix is surrounded, the reinforcement is surrounded by the matrix, the corrosion will not take place on the particle. Okay. It helps to safeguard the reinforcement. There are n number of, likewise, there are n number of uses of matrix and reinforcements are there that we'll see in the forthcoming slides. What are the functional requirements of matrix and the reinforcement? The first one, matrix. Matrix provides a medium for binding and holding the reinforcement or fillers together into the solid. It helps to retain the reinforcement at the appropriate place. Okay. Protects the reinforcement from environmental degradations. Environmental degradation, like the steel rods which is used in the reinforced cement concrete, if it is openly exposed during rainy season or corrosive environment or during salt environment, the steel rod will tends to corrode. Okay. So if it is being surrounded by the cement matrix, that has been saved. Okay. So that is, it will protect the reinforcement from the environmental degradation. Serves to transfer the load from one insert to another. Okay. One reinforcement to another reinforcement, it tries to transfer the load. Provides a finish, color, texture, durability, and other functional. Whatever you want, we can add it. Okay. So if the matrix naturally it is in blue color, you can leave as it is. But if you want in red color some additives may be added with the matrix. So it will give red. If you want a smooth surface finish, you can leave as it is. If you want a rough surface finish, you can make some kind of hatching pattern or any kind of things. Okay. So the matrix will help to provide finish, color, texture, durability, and other functional properties. If the component is used for floor laying, it should be slightly rough. If it is very smooth, there is the possibility of slippage. Okay. So you have to make the surface of the composite in such a way where it has required applications. Okay. Based on the applications, the surface has to be modified. Okay. So this thus can be attained by means of matrix material. Matrix is a binder material that supports, separates, and protects the fibers. Matrix have lower density, strength, and stiffness than fibers. That is in terms of fibrous composite. Compared to matrix, which one is stronger? Reinforcements are stronger. Okay. Cement, the stones, and the steel rods will be stronger, whereas the matrix material will be the softer material. Okay. Which will have the lower density. In the case of thermoplastic and thermosetting plastics, these two are the commonly used. Commodity and engineering plastics will be used as a thermoplastic polymers. Uncured resin should wet the reinforcement properly, and on curing it should have good adherence to the fibers. So the bonding strength of any reinforcement, which is purely depends on its wettability. That is the wettability of the reinforcement. That is why you should have seen in your house construction or masonry construction, while they are constructing a wall by using bricks and the cement mixture, what they will do? Before putting the brick on the wall, they will dip it in the water and they will put. Have you noticed or not? Okay. Have you noticed or not? So, by inserting it to the water, they are making the brick to be more wettable. That means that the passages will be already created. So, if the brick is placed on the wall, and if you place some amount of the cement material over the brick, so wherever already path is created, through that path the cement will try to slightly enter. If it enters, the bonding strength will be good. Okay. So if you don't dip the brick and if you place it on the wall, if you just put the cement mixture over here, then that the cement mixtures will not get into the pores. Okay. So that is why the bonding strength of the composite purely depends on wettability of the reinforcement, how much it is being wetted. Okay. So that wettability has been attained in the case of composite materials during the matrix wetting stage. So if you are, say for example, if you are sticking two papers by using fevicol, the fevicol initially will be in the form of liquid. Okay. Once it is being liquid, you can easily able to spread out. Okay. If it is immediately cures, you cannot able to spread out. Okay. So due to its liquid stage, you can able to spread out to the entire area. In such a way, due to its liquid stage, the reinforcement will be able to wet out completely. Once it has been cured, then the wettability will not be. Okay. So during its uncured resin, before curing, before settling, okay, uncured resin should wet the reinforcement properly, and on curing, it should have good adherence to the fibers. If it is completely wetted, then that will give good adherence, good strength. Okay. So for this, the uncured resin will be useful. That is the functional requirement of a matrix material. To hold the fibers together and acts as the medium for external stress to be applied through the fibers, which further transfer load from fiber to fiber. Okay. That is the combination of the first two points. It holds the fibers in the same direction and it will transfer the load from one fiber to another. In general, matrix material is the softer material. Matrix is being softer and more ductile than the reinforcement. Here they have coated fiber. Okay. That is by coating fibrous composite they have explained. In general, than the reinforcement, it is used to add the fracture toughness and prevent propagation of cracks. So if you are using the matrix materials as the ductile in nature, it will try to absorb some amount of shocks or impact. If it is a brittle, then easily that will break and the crack will be initiated very fast. Okay. So in such a way, the matrix, since the matrix material is the softer material, ductile material, it will absorb some amount of shocks, or it will absorb some amount of loads, or it will absorb some amount of impact loads, and accordingly the load will be distributed. Okay. Since it is a ductile and a softer material, even though a small crack initiates in the composites, that will not be propagated. If it is of a brittle material, a small crack creates, then that will be scattered very quickly. That you would have noticed in some of the glass pieces. Maybe in automobiles, buses or cars, you can see if a small crack is there, during a couple of days, the crack will be extended and the crack will go very quickly. But that will not be there in the case of mild steel sheets. If in the mild steel sheets, if any hole is there, that will not spread out. If any crack is there, that will not propagate very fastly. But if you have a glass plate, if a small crack is there, upon application, the crack will be easily extended or it will easily propagate. Okay. So in such a way, since the matrix material is softer, that will help to reduce the crack propagation. Right? To be chemically and thermally compatible with the fiber, to protect fibers from abrasion, environment, the chemical reactions, from chemical and other environmental reactions. Protect the fibers from abrasion, environmental or chemical reactions. Sometimes the composites may be used in seashore or near seashore applications. There the reinforcement will corrode very quickly. Isn't it? So if it is covered by the matrix, then the reinforcement will not subject to corrosion and other either acidic environment, not only corrosive environment, sometimes acidic environment. So it will safeguard the fibers from any kind of environmental degradations. Bonding force is critical to prevent the fiber pull-out. So if the matrix provides a better bonding, then the fiber pull-out will not be there. If the composite is made up of fibers, then the fiber will not pull out very easily. Okay, if the bonding strength is perfect. If it is not perfect, then the fiber pull out. The matrix need to be chosen to fit the conditions of the environment that will be located in. So based on the composites being used, accordingly you should select the matrix material. Sometimes if you make the composite plate, if it is used in a very hot environment, you should not use the thermoplastics or any kind of matrix material. During its application itself, that will melt it and that will lose its property. Likewise, and also by selecting the matrix, you should appropriately select the viscosity of the resin and the gel time and the curing system. That is a curing time also. Next is the reinforcement. Till now we have seen the matrix. What are all the purpose of the matrix? Now what are the purpose of the reinforcement? Either it may be a fiber or particle or laminated sheets or meshes water. So the primary function of the fiber or reinforcement in the polymer matrix is to carry the load. This is the main load carrying member. So even in the case of reinforced cement concrete, steel reinforced cement concrete, steel and the aggregates will take up more amount of load. Whereas the cement will be used to hold the steel rod and the coarse aggregate, and it will help to transfer the load. Obviously it will also take some amount of load. Cement mixture will also take up some amount of load. The percentage will be lesser. Okay. So this is the major amount of load will be taken care by the reinforcement. Smaller amount will be taken by the matrix material. That is why this is called as the principal load carrying member. Reinforcements are the principal load carrying members, and whereas the matrix materials are the secondary load carrying members. Okay. Primary function of fiber reinforcement in polymer composite is to carry the load along the length of the fiber to provide strength and stiffness in one direction or multi-direction, depends on the fibrous stacking sequence. High modulus of elasticity and high ultimate strength for efficient reinforcement. Reinforcement can be oriented to provide tailored properties or custom-made properties. If you are making this shape of the duster by means of a fibrous composite, if you are going to use it for a tensile application alone, okay, not for the transverse load applications, okay, it is going to use it for a tensile load applications alone. You can stack the reinforcement only on the longitudinal direction. After curing it, if it is being subjected to tensile load, it can take up more amount of load. Okay, if the duster has to take 30-degree orientation of the load, then you have to stack the fibers in 30-degree. Then if you are giving 30-degree orientation of the load, then it will take more amount of load. So whatever may be the load being applied on the composite, accordingly you can manufacture the composite. That is called as it can provide tailored properties or custom-made properties. Where you want more amount of strength on the composite plate, that can be made. Okay. Reinforcement can be oriented to provide tailored properties in the direction of the loads imparted on the end product. Good wettability or a coupling agent should be added to get the more amount of strength. If the matrix does not wet the reinforcement properly, you need to add some more additives. Okay. Even in the case of masonry works, cement and water, what they have mixed earlier, does not wet the brick completely. You should have more amount of water. You should have add more amount of water in such a way that water and cement mixture will be more thinner, and that will wet the bricks very quickly. Okay. So, or any kind of coupling agents, it may be additives or chemicals, whatever maybe it can be added to make more amount of wettability. If the wettability is higher, then the strength will be higher. Variation of a fiber shape between the individual fibers should be as low. So normally, if you select particulate composites, the particle size should be as uniform as possible. As minimum as possible to get the more amount of strength. Whatever may be the shape should be uniform. Then only you can able to arrive what will be the strength of the composite. Okay. Even the last point will also is that the diameter and shape of the fibers should be uniform. If it is a fiber. If it is a particle, the size of the particle should be uniform. Stable and retain their strength during handling and fabrication. So in general, the structural properties of the composite materials are derived primarily from the fiber reinforcement or simply reinforcement, not from the matrix. Okay, not from the matrix. So the primary property of the composite will be derived from the reinforcement only, not from the matrix material. In a composite, the fiber contributes or the reinforcement contributes high tensile strength, enhancing properties in the final path such as strength and stiffness, rather than the matrix material. So by listing out the functional and uses of matrix and reinforcement, now we can see what are the advantages of composites. So the composites will have high strength to weight ratio. So it is very, very important. If you ask questions in an interview, what will be the advantage of composites? Generally they will say that the composites will be used for high strength. That is not correct. Compared to its weight, it will give the higher strength. The steel will have some amount of strength. With the same size, if you take the composite material, that will not give that much strength. Okay. Compared to its weight, that will give higher amount of strength. That is why you should represent that the strength to weight is the one word. Composite will give higher strength to weight ratio. Higher strength to weight ratio. Energy efficient material, corrosion weather resistant or acidic resistance, or whatever properties for specific design conditions. So whatever may be the design conditions, if the duster has to take transverse load, accordingly you can stack the fibers in the transverse load. If it has to take the longitudinal load, you can stack the fibers in the longitudinal direction. So specific design condition, directional properties, complex shapes can be made very easily. Now we will see the polymer matrix composites. First we will see the polymer matrix composites, then we will go for the metal matrix and ceramic matrix. So as we discussed earlier, the reinforcement may be of any material, whether it may be another type of polymer, or it may be metal, or it may be non-metal, or it may be a sand or stone, or any kind of ceramic, any kind of material. But the matrix material should be of polymer. That is the polymer matrix composites. So in the case of polymer matrix composites or metal matrix material will be classified as the continuous phase, since that will have the continuity to others. But whereas in the case of reinforcement, continuity may not be there. In the case of continuous fibers, you can see the fibers are continuous. If it is of particles, you cannot see the continuity. That is why the reinforcement comes under discontinuous phase, whereas the matrix which comes under continuous phase. You can see this is the matrix alone, and you can see this is the composite fibers surrounded by the matrix. This is matrix and the reinforcement. This we have already seen. So in general, polymer matrix processing, there are based on the types of matrix, polymer matrix. You know the classification of thermoplastics and thermosetting plastics. So that the definition of the classification we can know very well. Maybe you would have studied in UG starting from schooling itself. Okay. Thermoplastics and thermosetting plastics. Based on these two categories, some of the processes has been listed out for polymer matrix processing, polymer matrix composite processing. If it is a thermoset polymer matrix, and layer, spray techniques used, then filament winding, full torsion, resin transfer molding, autoclave molding. These processes will use the thermoset matrix. And in the case of injection molding, film stacking, diaphragm forming, thermoplastic tape laying, this uses thermoplastic type of the matrix material. We will see one by one. And these are all the majorly used method of polymer matrix composite production: and layer process, full torsion, compression molding, resin transfer molding, resin injection molding, vacuum bag molding, spray technique, filament binding. Okay. Then other processes are also there. These are the most widely used. Right? And most of the engineering terms or engineering headings will give its process definition on the heading word itself. Most of the engineering terms. Only few will not describe about the process. If you just list out hand layer process. From the name itself, you can slightly get an idea that the process will use hand. Okay. By using hand, a layer can be made. You will not use any specific equipments. By using lighter equipments, lighter tools, you can fabricate the composite and layer process. The next one is the pull torsion. That is nothing but, maybe you would have studied about the extrusion process. Have you studied extrusion? So it is a combination of pulling plus extrusion. That is called the pull torsion. Pulling plus extrusion. Have you studied extrusion in your undergraduate or not? Extrusion. What do you mean by extrusion? Or simply describe the process. In a cylinder, you have to pour the raw material, place the raw material by using piston. If you push it, on the other side if you have a hole, with the water will be the shape of the hole, the material will come out. Isn't it? That is the extrusion process. Okay. That is similar to that of either injection molding or extrusion. Okay. Here there are two categories you would have studied: forward and extrusion and backward extrusion, or direct extrusion or indirect extrusion. Have you studied or not? Huh? Extrusion? Retraction. It is a forward and a retraction type. So you may be having a cylinder. And the material will be placed here. And you will have the piston. After placing this material, If you want a square shape, then the square hole may be here. So with the whatever may be the shape of this hole, if you give more amount of pressure, the material will be squeezed and that will be extruded. Okay. So if you give some amount of force, the material will be extruded. Okay. If you have a square hole, then the square shape of the component will get. If you have a hexagonal, then you will get a hexagonal or pentagonal shape. Or if you want any other shape, that shape of the component will come out. Okay, in linear manner. Okay. And if the application of this force and the application and the direction of the force and the job which is coming out from the die or the same direction, then that is called as direct extrusion. Okay. In the case of indirect extrusion, this side will be entirely closed and here itself one hole will be made. So if during pressing, the job will come out here. Okay. So this is called as indirect extrusion. Okay. So depends on the space availability, depends on the requirement of the customers, depends on the machine features. This will be classified either direct or indirect extrusion. So in the case of composite, the same thing, the composite mixer, matrix and a reinforcement are mixed together, that will be placed here. Okay, that will be placed here, and if you are pushing it, the job will come out. That is called a simple extrusion process. Okay, instead of giving pushing force by pulling the component, you can take the specimen. Okay, that is called as a pulling extrusion process. Here you will give the push force and the job will come out. That is called as a pushing extrusion. Okay. In the case of pulling extrusion, initially it will be made to come out. Then by holding this component, you have to pull it, and the job will come out. This is called as a pulling extrusion. That concept will be used in the case of pull-to-pull process. And the next is the compression molding. I think that you know very well. There are two molds will be there. So one will be the bottom and another will be the top mold. This will have the whatever may be the shape to be formed, and the raw material should be placed, and that will be compressed, and the material will be formed. That is the compression molding. Sometimes the compression molding will involve temperature also. So along with the pressure, temperature may also be given. Depends on the curing system of the matrix to be selected. Okay. Then the next is the resin transfer molding. So resin will be transferred to the mold part. Say a closed mold will be there, mold will be there. Within the mold cavity, reinforcement will be stacked. Only reinforcement alone will be stacked. Mold will be closed. Then you will have a hole. Through that hole, you have to inject the resin. Then the resin will be spread to the gaps of the mold. Then that is called as the resin transfer molding. And if the resin is transferred, sometimes due to gravity itself, and sometimes with some amount of injection pressure, you need to transfer it. Accordingly, that may be called as resin transfer molding, resin injection molding, and vacuum assisted resin transfer molding also. Okay, that classifications, everything will come under resin transfer molding. Then the next one is the vacuum bag molding, which is the most widely used method of polymeric composite manufacturing method, which will give the high quality component. Which will give the high quality component. Okay. And the next one is the spray up technique. Then filament winding. Last one is the filament winding. So it depends on the component size and shape, and what depends on the quality requirement of the composites. One can able to select what is the type of composite production method. Okay. And among these methods, some of the processes will use the open mold fabrication, some of them will use closed mold fabrication. Can you tell me among the, with this explanation, short explanations I have given about these processes, can you list out what are all the processes which comes under closed mold, what are the processes which comes under open mold?
Pultrusion process open.
Pultrusion is the open mold.
Filament.
Compression is the
Closed mold.
Closed mold. Since you will have the closed mold, within this the reinforcement will be stacked and compression. That is the two.
hand layer open.
Hand layer is the open mold. Very good. So vacuum back molding is the that will have two parts, closed as well as open.
Spray up technique.
Spray up technique is the open. Okay, filament winding is also open. Okay. So mostly compression molding and resin transfer molding will be closed categories. Right? So first we will see the open mold fabrication techniques. So hand layer, sprayer, tape layer, filament winding, autoclave. These are the open mold. The remaining is closed molding. Right? So the first one is the hand layer method. It is the simplest method which will be used for preliminary studies in research applications, as well as wherever you don't want higher amount of quality, there you can select the hand layer method. Okay. The quality is not a major constraint, you can use the hand layer method. Wherever quality is the major concern, which method you should select?
Back.
Very good, vacuum back molding. Just in the previous slide I told that vacuum back molding will give you the very quality fibrous polymeric matrix composite product. Okay. So this is the hand layer method, is the simplest process. Just I will explain with before telling about each and every steps. So it is nothing but it's an handmade, laboratory made method. This hand layer method, that is nothing but preparation of a plate-like structure or whatever may be the shape required. Accordingly, you should have a pattern or a reference table. So, with respect to the table, the component can be made. With respect to the table, component can be made. If I want a plate-like structure to be made, a plate-like structure of this A4 size paper of a composite plate of a 10 mm thick. For this, I should select a flat plate. If I want a curvature type of a component, I should have a plate of curvature. Okay. Since I want a flat type, so flat type table should be taken, and on top of which the reinforcement and the matrix material to be placed. Once it has been cured, this can be taken away. The plate can be taken away. Okay. So for this, a mold pattern should be taken. A smooth mold pattern should be taken, and on the pattern, you should apply a non-sticky agent. Okay, either gel or sometimes mostly they will use
Turpentine.
which one?
Turpentine.
Turpentine. Wax plus turpentine or any kind of non-sticky agents you have to apply. Mostly they will apply wax, or in the normal laboratory purposes, they will use the simple OHB sheets. They will put on OHB sheet, and upon curing, the sheet will be taken off very easily. Isn't it? So either you can apply the wax by using brush, then you can stack the required amount of reinforcement and the matrix material with respect to the required thickness, then finally you can take it. So the first step is preparation of the molded table. Depends on the required size of the composite plate to be manufactured. A table should be taken, and the table should be applied with non-sticking agent. That is called as a release film. That may be called as a release film or non-sticking agent. Either it may be wax or simply a one OHB sheet. Okay. Then on top of which, you should take both the reinforcement and the matrix material to the required quantity. If you are going to make a plate of this size of thickness 10 mm, say for example the layer of the reinforcement are 10 layers, and the matrix material 500 ml liquid of epoxy resin. Okay. These two will be taken, and first the epoxy resin should be slightly poured, and that should be spreaded to the entire area by using rollers or brushes. Okay. So first the resin should be spreaded. Okay. And once the resin is spreaded, so one layer of reinforcement should be depends on the required size. Initially you have to cut the reinforcement mat, and the first layer you have to put it. Once you put the layers, it will not completely wet out. Okay. during placing of the first layer, in between the layer to the surface, some amount of the atmospheric air will be there. Sometimes that will also be clogged between the layer and the surface. So that has to be taken away. Otherwise, some hole will be created. That will be called as a pores. Okay. Once you place the reinforcement, you need to completely press it. Okay. By means of a roller, you need to completely roll it out. Or you need to press it out. Okay. So that is done by means of rollers. What they are using, that is called as a rollers. Okay. This is rollers. Once you placing of the reinforcement, you need to completely roll out, which will help to escape the atmospheric air which is present between the reinforcement and the surface. Okay. And also it will try to completely wet the reinforcement with the matrix material. If you just press and roll it, the reinforcement will be completely dipped with the resin. Okay. Then again you have to pour the resin, you have to spread it out, then the next layer you have to place. Again you have to roll it. This has to be repeated until the required thickness has to be achieved. If there are 10 mm thick is required, if each layer contributes 0.8 mm, then 10 numbers of layers you have to place, then the matrix thickness will also be added. Finally you will get 10 mm thick plate. Once you have completely stacked all the 10 layers, then on top of which a non-sticking film similar to that we have placed on the bottom, we have to place at the top. Then a plate similar to that of the bottom plate has to be placed on the top. Then you can place some amount of counterweight. Okay, to give some amount of uniform pressure. Okay, uniform pressure in such a way that 10 mm will be uniformly maintained. Okay. If it is atmospheric cured, then you can leave it for either 5 hours, 10 hours, depends on the curing system of the matrix material selected. And after 10 hours, you can remove the top plate and you can peel off the OHP sheet, that is the non-sticky film. Then the laminate can be taken. Bottom side also you can peel off the OHP sheet. Then finally the laminate will be ready. Sometimes the matrix material will be cured only on hot environments. With the elevated temperature only, the matrix material will cure. So in such cases, once you made the laminate, the complete laminate should be taken and that should be placed on your oven. There, the required amount of temperature for a specific duration it has to be maintained. Say for example 80 degrees centigrade for 5 hours. Okay. If you switch on the oven for 8 hours or 5 hours, then after 5 hours you can switch off the oven, then you can take away the sample. The matrix will be completely cool. Okay. This is the hand layout method. Okay. The procedures have been given here. And by seeing this, you can list out what is the advantages and disadvantages of the hand layout method. It is the most widely used method, low tooling cost, custom shape can be made. So whatever may be the shape required, if you want a slight projection on the plate itself, a projection made on the table itself, and accordingly you can stack the fiber that will give the required amount of shape. Okay. Custom larger and complex items can be produced. Labor intensive. It's a labor. Everyone cannot make the composite very easily. Some kind of experience should be needed. And skilled labor should be needed. Skilled laborers will demand for more amount of cost. Okay. So labor intensive, low volume process, sterile emission. Some of the matrix materials, while adding some amount of the additives, which will create some amount of fumes. That if it is inhaled by the users, that will create some amount of problem. Okay. So sterile emission will be there. Accordingly, you use some other safety measures. Quality control is entirely dependent on the skill of the laborers. So the main problem the hand layout method is the inconsistency. So that cannot be obtained in all the laminates. Say for example, if I am making 10 mm thick plate of 20 numbers, I am using a skilled labor. He is having 20 years of experience, the same amount of material, same tooling, same person. All the 20 laminates will not be having the same quality. Maybe first 5 component plate what he has made will be having higher amount of quality. The last 10 plates may be lower in quality. or thickness may be slightly lesser also. So during rolling, initially for 10 pieces you will give a slight amount of pressure, then due to fatigue nature of the human, and the last time you will not concentrate more on the same to the previous. So consistency in all the cases, all the plates will not be there in the case of hand lathe method. But if it is of machine operated, we can expect all the 20 plate will have the same quality. Right? So that is the inconsistency is the major drawback in the case of hand lathe. Even if you use the same labor, same material, same environmental conditions, you cannot expect the same property in all the products. Okay, that is the. These are the example of the hand lathe products, like cupboards and doors, window doors, main doors, even these structural buildings. There are a number of applications are there. Okay, even boat hull, boat superstructures. Nowadays, even some of the automobile components are where quality is not a matter. They are made by using hand lathe method. And the next is the spray up method. Spray up method. So it is the slight modification of hand lathe method. In the case of hand lathe method, we will be using the rollers to remove the entrapped air and to wet out the fibers. In the case of spray, that is nothing but through the spray process, the material will be like painting, however. So in the case of painting, only the liquid alone will be there. In the case of composites, polymeric composite manufacturing, along with the liquid matrix material, fibers should be cut into smaller pieces. That should also be mixed. So along with the matrix material, small pieces of fiber should also be made. You cannot use the long fibers here. So the strength of the composite will be obviously lesser. Okay, since you are not using continuous fibers, short fibers will not give good strength. So wherever you need a lesser strength, there we can select the spray method. Okay, so here the maximum fiber length may be 1 to 2 inch, 25 mm to 50 mm, maximum 50. That will be sometimes even lesser also. Okay, so these fibers will be mixed with the matrix material, and reinforcement fibers will be cut into smaller pieces. That should also be mixed here, and the whole thing can be sprayed on the mold. Depends on the curing nature of the matrix material. The matrix materials can be taken in either one tank, and the fiber will be taken in another ray. So this is the fiber ray, and these two are the matrix materials. This is a resin, is the matrix with the catalyst, resin with accelerator. Maybe you would have studied about the catalyst and accelerator in your schooling itself or undergraduate itself. What is the difference between these two? What is the purpose of these two? Catalyst and the accelerator.
Catalyst actually actuates the reactions.
Very good. So,
acceleration, the speed of the force of.
Very good. Catalyst, the resin will be in the form of liquid. We want to convert the liquid into solid. That is the process of curing. After composite is made, it has to get cured. Okay. So to convert or to initiate the process of converting from liquid to solid, this catalyst will be used. If we add some amount of catalyst, that moment itself it will start reaction for converting this liquid into solid. Maybe after 1 hour or 2 hours. If you want to reduce the time within 20 minutes or half an hour, it has to convert from solid to liquid, then you need to add some more additives which will speed up the process. That is called as accelerator. Okay. Instead of 2 hours curing, within half an hour the resin will be cured. Okay. So that is the catalyst is the initiation. This is the initiator, and this is the to speed up the process. Okay. So sometimes they will take it in 2 different tanks, or in some cases all the things they will put it, resin, catalyst and accelerator, they will put it in a single tank and they will use it. Okay. This continuous fiber will be taken on a ray, and the entire thing will come here. It will be similar to that of a motor, which will have in the cutter section. This long fiber will be cut into smaller pieces. these two liquids will come here, everything will be mixed, and the mixed composites will be spread on the table or the mold or whatever. Okay. You can see the immersion. This is the chopper. The continuous fiber, if it comes here with the cutters spread on the rollers, that will be cut into smaller pieces, and the catalyst and the resin mixer will also be. Or in some cases, all the things will be taken in a single tank also, right? And that will be sprayed. Here, the main problem is, say for example, if you want to make a composite plate of this shape, right? And the entire matrix and the reinforcement have been taken, and this will eject the composite material, that is the short fibers along with the matrix material, and that should be coated over the surface of the mold. Okay. So how much amount of the thickness required, accordingly the speed of the gun has to move. Okay. If I want to coat the 1 mm thickness, I have to move very fastly and I can finish up. If I want to get a 10 mm thick, I have to move slowly. Okay. And sometimes with the inclined surfaces or vertical surfaces, the resin will flow down. Okay. So in such cases, you need to give some extra amount of time for curing, or in such cases, accelerator to be added slightly more. Okay. That is, during one time, you need to move the gun from left to right, then right to left likewise, then from top to bottom. Then the second layer again you have to put. Likewise you can add, then you can get more amount of the thick material which will be deposited on the mold. Okay. So to speed up the process, either you can use the higher amount of accelerator. Again the drawbacks which depends on the skillness of the operator. Okay, skillness of the operator. If you are given the instruction to the employee to make a 10 mm thick plate, if each layer, each time, if he makes a 2.5, 4 times he has to move. Okay. So instead of moving slowly, if he moves fastly, then on the top plate, you will be having lesser amount of thickness. Or if it moves very slowly, then the thickness will be higher. Okay. So the uniform thickness, which is purely depends on the movement of the gun, and which is done by the operator. Okay. So for this, to slightly automate this process, they will use some kind of automated robotic mechanisms. Okay. If you are producing a component of more numbers, you can make the automate. If it is a job orders, it is cost is very high. Okay. So if it is the component number is very high, you can go for automated mechanisms. There the gun will be constantly moves from left to right, then next layer, and next layer likewise. Accordingly, you will get the uniform. Okay, it depends on the operator. This is the other diagrams. In both the cases, hand layer or sprayer, deposit layers are raised with rollers. Here this has been given that what is the purpose of catalyst in the accelerator. Advantages of hand layer and sprayer. Tooling cost is low. There is no tool is required. Okay. Only the roller and sprayer like this. Semi-skilled workers are easily trained. You can train up the person very easily. Design flexibility. Mold and inserts and structural changes are possible. Sandwich constructions are possible. Sandwich construction. One layer you can use one fiber, and another layer you can use a steel rod, and another layer if you want to use metal mesh, water maybe, or another layer maybe metal mesh, aluminum mesh. Like this, sandwich constructions are possible. Large and complex items can be produced. Large and complex items with limited numbers. If you are going to produce the large and complex items by using compression molding, first you need to make the mold, isn't it? That is very costly. If it is a mass production, you can make the mold. For job orders, that can be very easy. Minimum equipment investment is necessary. The startup, lead time and the cost are minimal. Disadvantages in both the cases: labor intensive, low volume process, longer curing times. That is, if you are adding more amount of accelerator during the gun itself, sometimes it will be get cured. Okay. So you cannot add more amount of accelerator also. Okay. Since the processing, it requires some amount of time. So the curing time is higher. Production uniformity is difficult. That is the consistency. Uniformity will not be there. Waste to factory is high. Even though in the case of spray process also, some amount of the material will be sprayed out. The waste to factory is high. And the next is back molding. That we will see in the next class. Okay. Okay. Thank you. If you have any doubt, you can raise the questions. among GAN layer and the sprayer method. How this will proceed.